Hello, my name is Corey, and today I'll do a little video on FTC programming basics. It's a follow-up to the previous video on FTC programming basics. First, I'll go over what's in the video so you'll know what to expect. We'll teach you how to configure robot hardware using the robot controller phone app. We'll teach you about the hardware map and how to use it through your code and how that interacts with the configuration file. A little bit of Java review. This includes classes, objects, variables, methods, stuff like that, and how to create your own simple opMode. It won't do much, but it should actually be able to run on your robot, and that should be pretty cool. Throughout the video, we will be referencing robot hardware. So if any of the following words don't make sense to you, then check out our video on robot electronics and hardware. If you don't know what a core motor controller, a core servo controller, a device interface module, any of those are, then you should check it out. Also, if you don't know what a DC motor, a servo, or any of the sensors are, and make sure you know that the phone is the brain of the robot. So the robot controller is the central intelligence of the robot. So now we'll talk about robot configuration. When you configure robot hardware, it's basically telling the robot what's plugged in and where. On your robot there is hardware like a motor controller or a servo controller or a device interface module. And your robot needs to know what's plugged into it and where. So this is how you tell the robot where everything's plugged in. So if we go on to the pushbot build guide on firstinspires.org, they will show you how to create your own configuration file. So first you open up the robot controller phone app and click these three dots, configure robot. And then here, if you have created any configuration files, they would show up here. We're going to do new. And then something like this will come up. You have to click scan, which this will scan your robot for any hardware or controllers on your robot. So this is an update to the video. In 2017, first released the Rev Expansion Hub, which offers an alternate to the Robotics controllers. So after you hit scan, depending on what electronic system you have, you'll either see this Rev Expansion Hub or the Robotics controllers. So if you click through, you'll get to a menu where you can name all your motors and servos. This process is very similar to the Robotics process, so we'll just go back to the old video and you should be able to figure it out from there. Here, you can see the different controllers you have, or the different hardware. These are the physical objects on your robot. This varies per robot, so you might have a motor controller and a servo controller, but you might not have any more motor controllers. But for this example, they have two motor controllers and a servo controller. So if you click on any of these, you can go within them. For a motor controller, they have two ports, which represent the physical ports on your motor controller. So two motors can be plugged into one motor controller. So these are the two ports that you can plug motors into. Scroll down to the servo one. So if you come down, they're going to go within the servo controller. You can rename the controllers, but we don't do that often because it's not necessary. As you can see on the servo controller, there are 6 ports. If you scroll down, there are 6. So these represent the 6 physical ports on a servo controller that you can plug into. Now you need to rename the actual servos that are plugged into the controller. So if you had a claw servo plugged into port 1 of the servo controller, then you need to name it something that makes sense to you. So something like servo claw, servo underscore claw, or something like that, that makes sense to you. So they named theirs left hand and right hand because that makes sense to their particular robot. And then they did the same thing for motors, and if they had sensors, they would do the same thing for sensors as well. So motors, you might do left drive, right drive, and then sensors, you might just do color sensor, touch sensor, anything like that. So once you're done with this, you just click Done, and then Save Configuration. Be sure to activate the configuration file you want to use in the list of configuration files, because if you don't, your robot won't know where everything's plugged in. So now we'll talk about the hardware map. What is the hardware map? The hardware map is basically your configuration file that you just created. So when we code in Java to find out where anything's plugged in, we call on this thing called the hardware map, which is your configuration file. So whenever we need to find out where anything's plugged in, so if we need to find out where a motor's plugged in or a servo's plugged in, then we can just call on the hardware map, which looks within your configuration file on your robot controller phone. So now some examples of hardware map code. So for this example, we have a motor named left motor, and we're assigning it the value of something in the hardware map. So the equals is called an assigner, and that basically means that whatever's on the right side of the assigner, we're going to put into the whatever's on the left side of the assigner. So in this case, the left motor equals hardware map.dc motor.get, and then whatever's in the quotes, that has to match what's on your configuration file. So if on your configuration file you name something called left drive, and that was where your left motor is plugged in, then it has to say left drive. If it doesn't match, then you're going to get errors and your robot will crash, and it won't know where that motor is located. So notice that it's hardware map.dc motor.get, but for a servo, it's hardware map.servo.get. So this one's pretty much the same thing. It's servo claw equals hardware map.servo.get and servo claw. Then you can do the same thing with any sensors you might have. So a generic way of saying it is the name of your device equals hardware map.device, whatever your device is. So a motor, servo, touch sensor, .get, and then whatever the name of the device you had listed in the configuration file was. So now we'll get into variable declaration, but first a quick review of some of the things we learned in the last video. Java is an object-oriented programming language, which means that everything in Java is represented as an object. A Java class is a set of blueprints to create an object. And objects have two basic characteristics: what they know, called variables, and what they do, called methods. So we're going to be talking about variables. So we must declare a specific object type for variables. It could be a string, an integer, a boolean, a DC motor, a servo, or anything else, any other object. A variable declaration has two basic parts: what type of object it will be and the name of the object. So first we're going to declare the type of the object. So we'll say it's a string, and then we'll declare the name of the object. So now let's look at some examples of variable declarations. We could have a string, some words. So a string is the class or blueprints that we're going to use to make an object called some words. For now, just think of a string as words or sentences or phrases. We could also have a string called player name. It's the same idea. So we could have a boolean named isRunning, and a boolean is basically a true or false statement. So now that isRunning is a boolean, it can only have true or false within it. It can't have anything else within it. We could have an integer named example number. So an integer is basically an integer. It's a whole number, and you couldn't put any decimals or anything in it. And then a float named drive power, and a float is basically a decimal point number. So they can be whole numbers, but this gives you the availability to use decimal points. So now some examples of variable declarations you might see in FTC. So a DC motor named left drive. We could name this DC motor anything we wanted to, but you probably want to name it something that makes sense for your robot. So if you had a motor that's controlling the left wheel, then you might want to name it something like left drive. And then we have a DC motor right drive. We have a servo named claw arm, and a touch sensor named touch. So let's take a closer look at our DC motor. So first we need to declare the variable. So we say DC motor left motor. So we're creating a object called left motor from the blueprints of the class DC motor. You can think of this as creating a container. There's actually nothing inside of left motor right now. It's just an empty vessel that can hold a DC motor. So next you assign the object. So over here on the right we have our hardware map example from earlier. So we'll say left motor, which is the name of our DC motor container that we set up earlier, and then we say equals with the assigner, and then on the right side of the equals we get from the hardware map a DC motor named left drive. So now the left motor equals the thing that we set up earlier in the configuration file named left drive. So if we went out to the hardware map and got a servo, then it won't work because our left motor is declared as a DC motor. It can't be a servo. So now instantiating a class. So first, what is instantiation? Instantiation is creating an instance of an object. So remember earlier when we had our empty container of DC motor left wheel. So that didn't actually have anything in it. And then we did DC motor left wheel equals hardware map.dcmotor.get. So we were creating a new instance of the DC motor class by putting something into the container. So if we had DC motor left motor equals new DC motor, we are now creating the empty container, DC motor left motor, and then we're creating a new instance of the DC motor class by saying new DC motor. So now left motor contains a DC motor. So this line is how you instantiate. So this here would be a generic DC motor. It wouldn't know where it's plugged in or anything. So that's why we use the hardware map, because when we get something from the hardware map, it returns the motor, but the motor knows where it's plugged in. So let's review what classes can do. So if we had a superhero class, that would be the class name. The superhero class has what it knows, which are called variables, and what it does, called methods. So the superhero knows its size, its weight, its superpower 1, superpower 2, hero outfit, color main, hero outfit, color secondary, catchphrase, has sidekick. So some things that the superhero can do: it can get size, get weight, set size, and set weight. And you'll see that kind of method a lot. They're called getters and setters, so that you can set a specific variable and then you can get a specific variable from that class. It can chase bad guy, use power 1, use power 2, say catchphrase. So some code to create a new superhero from our superhero class, which remember is instantiating a superhero. So on the left side we're declaring a new superhero named Superman. And then on the right side, we're assigning Superman to a new superhero. So we've instantiated a new superhero named Superman. But now, Superman only knows stuff that a superhero knows. It just knows generic stuff. It just has the default superhero stuff. But if we wanted to set specific superhero things specific to Superman, then we could do set size, set weight, and any other methods that would make Superman specific to being Superman. And then we get Superman. So you could also do it this way by saying superhero Superman equals new superhero, and then pass that class Superman stuff. So now Superman will be created already knowing stuff about him without having to call any methods. and then you could reuse the superhero class to instantiate as many superheroes as you want. You can make Superman, Baymax, Iron Man, Mario, and then once you instantiate all those, they create 4 new superheroes from that superhero class. So we're using one set of code called a class to create 4 instances of new superheroes. A more practical class for FTC would be a DC motor class. So the DC motor can know its power, its direction, its position, its run mode, its port number, and probably a bunch of other stuff. And things that it can do is set power, set direction, get power, get direction, set target position, is busy. So it has variables and methods just like our superhero class had. So we have our instantiation of the DC motor class called left wheel from before, and we can say left wheel dot set power. And when we're doing this, it's calling the set power method from the class DC motor. So in the SDK, they've included code for us, so we can just say left motor dot set power, which is pretty easy for us, but it actually goes out to the DC motor class and calls on this method called set power. So now let's get back to instantiating a class. So we could say DC motor left wheel equals new DC motor. So now we are declaring left wheel as a DC motor, and then we're assigning it the value of a new DC motor. So we've instantiated a new DC motor named left wheel. So we've created a new motor, and it's just a generic motor that knows the default stuff about itself. But we could do up at the top, we could say DC motor left wheel equals new DC motor and give it left wheel stuff. And then that will make a new DC motor with specific functionality. So more likely what you'll see this in FTC is by at the top declaring the motors by saying DC motor left wheel and DC motor right wheel and DC motor arm pivot and DC motor collector. So later you could use the name left wheel, which is the container for the DC motor, and then assign it a value of something from the hardware map. After you instantiate those 4 motors, you get 4 specific motors that know specific things about themselves, all from the DC motor class. So now we'll actually make our own opMode. Some of the things that we'll need to do to create our own opMode will be creating and naming our Java class, importing the opMode class and setting up our methods, the init, start, loop, and stop methods, declaring hardware, assigning the hardware using the hardware map, and making the robot drive forward. And last but not least, we'll need to register the opMode, because if you don't register the opMode, it won't show up on the phone. So to make our new opMode, we'll right-click the opModes folder, and we'll say new Java class, because we're going to make a new Java class. And then we'll name it something that makes sense, so just simple drive opMode. And then you hit OK, and it generates a little bit of code. We can see here we have our class named simple drive opMode, and notice that this matches it over here. If it doesn't match, it won't work. Now to make our class inherit all the traits of an opMode, we'll say extends opMode. So now our class is a opMode, so it inherits all the traits and behaviors of opMode. So now Android Studio is getting mad at us because it doesn't recognize opMode. A way to fix this is to import the class. So what importing means is that there's a default set of tools given to us in any Java class we create, and any class that's not part of that default set of tools we had to import. So opMode is not part of that set of tools, so we'll import it. So to import it, we'll just double click this, and we'll go over to the error light bulb telling us that there's an error. We can click it and it'll give us suggestions on how to fix it. So we'll import class, and then it'll auto create this import statement for opMode. So now Android Studio is still mad at us because when we extend opMode, opMode has two default methods that are made to be overridden, which means that we're taking over a method from the main class and writing what we want into it. So when it gets called by something else, it will call our code instead of the default opMode code. So we can click the we could click the arrow again and do implement methods, which will write the methods for us, but we'll just write them anyways ourselves. So we'll do a method public void init, and we'll do a public void loop. So now we have the init and loop methods, but a way to really emphasize that they're being overridden is to write the @override expression at the top. And now it's clear that init is overridden. We'll do it for loop as well. So now that we have our methods, let's declare some hardware. We'll declare a DC motor left wheel and a DC motor right wheel. So we have empty containers for the left wheel and the right wheel. DC motor is also not included in the default kit of tools, so we had to import it as well. Another way to automatically import is by pressing Alt-Enter, as Android Studio prompts you right here. So we'll press Alt-Enter, and then it will generate an import for DC motor. So now we'll instantiate our hardware. So we're going to put it in the init method because that's going to happen right when you hit the init button. So we're basically initializing our hardware, so it would make sense to put it in an init. So we'll say left wheel, and notice that Android Studio recognizes that left wheel is tied to this left wheel because they are the same thing. So now we're going to put something into the container. So we're going to go out to the hardware map, and we're going to go to the DC motor, and we're going to get, and then whatever we put in the configuration file. So for now, let's say it was left wheel. And then we can copy and paste it to do the same thing for the right wheel as well. So just change left wheel to right wheel, and change left wheel here to right wheel. So now we've instantiated our hardware. We have two functional motors. So now we'll make our robot actually drive forward. We'll put the code to make it drive forward in loop, which is going to happen from the time you hit start to the time you hit stop, over and over and over again. So we'll say left wheel dot, which means we're going to go to a specific method within the DC motor class, and then you can see all of these methods. You only need to know a couple of them. The one we'll be using is set power, so we'll say set power, and then we can give this motor a value from anywhere from 0 to 1, 0 being off and 1 being full power. So we'll give it somewhere in between, a 0.5, because we don't want it going full blast or anything. And then we'll say right wheel dot set power, and we'll give it a value of 0.5 as well, so it'll drive forward. So another way we can set powers to the wheels is, instead of actually having the powers like this, 0.5 and 0.5, we can create a new variable to hold the value of the powers. So we'll make a double, which is a decimal point number, which is also what you give it here. And then we'll name it drive power, and then we'll give it a value of 0.5. So now we've declared and instantiated drive power all in one right here. So now we have a new double named drive power, and it has a value of 0.5. So now we can just put in here drive power and drive power. So now it's essentially doing the same thing. We're setting the power to 0.5 on each of the motors, but if we need to change how fast the wheels go, we can just change it right here instead of having to change it in both spots. Which would also be really great if we wrote this code, if we wrote it 10 or 12 times, because then we wouldn't have to change all of that every 14 times. We could just change it once. So I know I said that this would make it drive forward, but currently it won't. And the reasoning behind this is that when we built our robot, you had to flip one of the motors 180 degrees to get a wheel on each side of the robot. So one of the motors is essentially going the wrong way. One way to fix this would be making this value negative, and now it would go forward, but instead we'll use a method of the DC motor class. So we can say right wheel dot set direction, and then we'll give it a direction. If you can't remember what to type to give it a direction, if you type anything in, Android Studio will give you a list of pretty much everything with that letter in it that pertains to the that pertains to your topic. So right here we can see this value right here, and if you want to select that, you can just click the down arrow key and then do enter, and then it'll select it for you. But we don't want it to go forward, so we'll change it from forward to reverse. So now if we tell the right motor to go forward, it will go the right direction, but in reality it's going in reverse. So now we have our completed opMode that will have our robot drive forward from the time you hit play until you hit stop. But we have not registered it yet. Okay, so here's another update in the new SDK. Because as you remember the first video, we have to register the opMode. To register it, if you remember for the first one, we just put it right above the class name. We put at and then teleop, because we're doing a teleop, and then we do enter to import it as usual. And then we do parentheses, name, and then you put the name that you want the opMode to be in the quotes. So this one will be simple drive, because that makes sense to what we're doing with our robot. And then we'll do group equals quotations and then whatever group it's in. And we'll put it in the group training, because this is more of a training opMode. And then since this is the registration, it doesn't need a semicolon, so just leave it with a closed bracket right there. So now that we've done this, it should be able to show up in the phone. So now we'll check to make sure that we've done everything we set out to do. So we did create and name our Java class. We named it Simple Drive opMode. We imported the class opMode, and we set up our methods init and loop. We declared the hardware. We made the empty containers. We made left wheel and right wheel. And then we assigned the hardware. We assigned it in the init method using the hardware map. And we made the robot drive forward in the loop method, but we also went a step further and made a variable to hold the drive power and reverse the direction of the right motor. And we also registered the opMode, so it will show up on the phone. Some useful code to remember and use in your opModes. You'll need to remember the hardware map, how to assign a value to your motors and servos and any of your hardware. And then you need to know name of the motor dot set direction, and then just DC motor dot direction dot, and then forwards or reverse. You'll need to know name of the motor dot set power, and then anywhere from 0 to 1, 0 being off and 1 being full power. So that's all for this video. Be sure to check out the next video where we actually get into how to control the robot with gamepads and even get into a little bit of autonomous routines.